Hi, this is Jacob Nash with JNGL. This is Unit 6, Lesson 4, and in this video, we're going to be looking at something called the side splitter theorem. Now, there is a specific definition for this, and I suggest that you look and see what it is in case you don't understand this, but I'm not necessarily going to just say what it is, because it's easier to see it visually. At least for me it is. So, really, here's the case. So let's just say we have two triangles here. And something I want to point out is that it kind of looks like if you do this, that there's only one triangle, but there's really two. There's this small triangle right here, and then the whole thing, but they're just kind of like on top of each other, if you think about it that way. So let's just say that how we can tell these are, well, let's just look at this. So we have congruence markings right here. That is for both of these triangles because this is two different angles right here because there's two triangles. And then let's say that these corresponding angles are congruent right here, and also these. Okay, there you go. Now let's just say we could label the points, but I don't necessarily need to do that yet, if at all. Now let's say that this length right here is 5. This is 3. This is 4. And let's say we're trying to find out what this one is. How could we do that? Well, what the side splitter theorem says is that, there's actually something crucial that I left off of here. I'm sorry. Another thing that you'd need to know to solve this is that these are parallel. That's the main thing. So if there's two parallel lines, basically the parts of the triangles will be proportionate to each other. That's basically what it's saying. So how you would be able to solve this is set up a proportion like this and solve by cross multiplying. So let's put 5 on the top. But something you need to be careful of in a problem like this is to not put 3 on the bottom, because this isn't a triangle side. This isn't. This is just part of this big triangle. You got to think about it this way in case you don't understand. This is the small triangle, and then the big triangle is around the small triangle like this. That's not a very good drawing, but it kind of gives you the right idea. So in that case, you would have to add these two sides, which would make this 8. On the other side, you could say 4. And 4 plus x might seem like what could go right here on the bottom. But the reason why that it's just x is because you're trying to solve in this way. If you don't know what x is, you can't add an expression on the bottom like that. So you just put x there for that. That's what you need to make sure of. Now, cross multiply. 5x equals 32. Okay, that's what we get. Now, let's divide like this. And we don't really need to simplify to a decimal in this case. Let's just say x equals 32 over 5. That is how you would solve. So, does that make sense? I mean, you can't say anything, obviously, but think in your mind. Does that make sense? Hopefully it does, because that's all you need to know. But this isn't the only layout that a problem could look like. So let's now, I'm not going to erase because that makes this weird thing like that. So I'm just going to do a very large size and color white. So let's cover that up and let's try a different problem. And we definitely don't want that big of a size, so let's just do this. Maybe Okay, so it won't always look like that with the triangles on top of each other. It could also look like this. So you have two lines like this, and another line like this, another line like this. And then you would have to know that this line is parallel to this line. If those lines aren't parallel, then it's impossible to solve the problem. And once again, let's add the congruence markings. Obviously, even if these markings weren't here, you would know that they're equal because vertical angles come into play once you know that there's parallel lines. Then, by the way, if you don't understand what I just said, you should skip back to Unit 2 to see that, because I explain more about that on that unit. Okay, there we go. We have this. So now, let's figure out what lengths I should just make it. Let's just make this one 6. Let's make this 7, 4, and let's just say you're trying to find that. So how would you solve it this time? Well, let's see. Well, we have the opposite sides here, 7 and 4, so that's how the proportion could be set up. 7 over 4 equals what? Well, it's going to be 6 over x, because these are the sides. Like, just imagine flipping this over onto that one, like this. What would meet up? These 2 points would meet up, and these 2 parallel sides would go on each other, and so you could see which ones would be on top of each other. So now you would need to do 6 over x. Really, the ones that land on each other are the ones that are going to be opposite from each other. So 7x equals 24. So once again, we get just some random improper fraction, and x would be 24 over 7. The last thing I want to look at in this video, as I was finishing writing that, is could you set up the proportion differently and get the same answer? That might be something you're thinking about. Well, let's try it and see what happens. 6 over 4 equals 7 over x. Let's see what happens. So now you get 6x equals 28. So then in that case, you would get 28 over 6. Well, let's just pull up the calculator and see if this is if those are equal. You might already know, but just to do it, let's see. So 24 over 7 is 3.42. Actually 3.43 if you round correctly. So, and then 28 over 6, what does that equal? 4.6 repeating. So in this case, it couldn't. If you flip just because you had it in different order, if you flipped it over, let's say 4 over 7 equals x over 6, in that case, you still could. You could flip it over, but you can't do it like that. Like switch out what sides the numbers are on. Sorry. So now you know there are different ways to write the proportions, but you got to be careful. So that is all for this lesson. Thank you for watching.